Welcome to this online session of digital logic and computer organization and architecture. This subject is for semester 3 in computer engineering. That was one query I saw in chat box. Is it for EXTC? Mainly it is for computer engineering. Only digital logic part is almost same for EXTC. And let me start with some introduction, because though we are meeting online, there is some formal way of teaching learning process, and I believe it starts with a teacher. So here I go, and here is my profile. You can have a look and know about your teacher before we start. I'm Professor Atul Oak, and I'm working with Vidyalankar Institute of Technology, Mumbai, as an assistant professor with the Department of Electronics and Telecommunication Engineering. And what you see is my academic qualifications and professional qualifications. This is my teaching interest. I teach system architecture, and in system architecture, I teach all these subjects: microprocessors, microcontrollers, your subject, which you see in highlighted green color, that is DLCA, embedded systems, operating systems, database management systems, and IoT. This is my domain. And I teach programming because system architecture is incomplete without programming. So I teach C, C++, Java, advanced Java, Python, and assembly language programming. This is my domain of teaching. And for you, it is DLCOA, which already I have highlighted. Proud to say that I'm with Vidyalankar for last almost 15 years, and great association, I will say. And teaching all these professional subjects for almost 21 years. So this is about your teacher. Now let's talk about subject. Here comes why you are on Friday 6:30. Subject is DLCOA. It is CSC 304 as per Mumbai University for semester 3 in computer engineering. And you will be appearing for 80 marks of written examination, 25 marks of term work, 20 marks of IA, which is of course average, IA1 plus IA2 divided by 2. Total 125 for the subject, all inclusive, and 3 credits for this particular subject. And what you see are the 6 modules in this subject, and what you see on other side is our plan. So we will start with chapter 1, chapter 2, then chapter 5, if you see, then chapter 3, chapter 4, and chapter 6. That is our plan, because I will be teaching the way you will understand, not because Mumbai University says that this is a sequence. Okay, so we will cover everything, but the way you will understand. Focus is your understanding, not the completion. So I hope you have noted our plan, how we will be moving. Don't worry that all details you will be getting lecture and lesson planning. This is just for reference in initial 10 minutes. And finally, I will need around 14 sessions of 2 hours and 15 minutes. Today is session 1. And of course, I may require 2 to 3 sessions more. So it is 14 min plus 2 or 3. That is the overall sessions required as per the modules, or to complete the modules the best, or in fact I will say in all possible ways. Okay, all sessions will be online. I'll be using ICT tools, my own PPTs, my camera, my audio, and my virtual board. Okay, and notes, most important. Soft copy you will get. Okay, we have our app in which those notes will be shared, but I suggest that you make a notebook for this subject, because as we proceed I will be giving you some dictation in between. Okay, because though it's online, some practices of physical classrooms we need to follow, and those good practices include writing reference notes. Okay, so I will be giving, but it will be very precise. Okay, I will not be spending much time on dictation. I'll be giving whatever is required, okay, as a notes. That completes my 10 minutes about myself, about subject, about plan, and here is my session 1 agenda. Point 1 I have completed. Okay, specifically if you are there from 6:30, point 1 we have done. What we are doing today, what's the agenda for the day? Lecture agenda. I will introduce number systems, chapter 1 I will start, and we will understand some conversions between the number systems. Okay, some discussion may roll over, because now we will be discussing for 2 hours and 15 minutes. So some rollover is possible during lectures. Okay, so we are ready to go. Just want to confirm all is good. If all is good, please type YES in chat box. YES I call as a magic word, and it indicates that all is good. I am audible, I am visible, and for me, it is an indication that you are there, not physically, but also, okay, your concentration. Okay, I can see a lot of YES in different permutations and combinations. That looks fine. Fantastic. Okay, we are good to go. Okay, this magic word will
Yes,
be
sir.
coming in between. Okay, fine. Let's go ahead. All looks good. I'll start with some reference. Okay, like I said, I will be giving you some notes. Okay, today only we will start. I will be dictating, so be there with notebook and pen if you are not carrying. But before I start, one very good textbook that you can refer is Modern Digital Electronics by R.P. Jain for module 1, typically number systems. This is a very nice textbook. Now we are going to colleges. Okay, all colleges are running physical, offline. So definitely you can visit library and you can procure this book. Okay, for module 1, that is the number systems and some concepts of digital electronics. Okay, anyway, let's move on. Just 1 minute, I am admitting some more students. Okay, now I will start with one question and you can unmute one at a time and you can answer that questions for all sessions I'm talking. Okay, see that if somebody is unmuting, you wait and then you can unmute, or you can use chat box also. Okay, for answering the questions. We have to avoid the chaos. Let's start with a question. And here is my question. My question is, what is a computer? Can anybody tell you what is a computer? You are from computer engineering. Any answers? You can unmute or you can use the chat box. Okay, Krishna tells an electronic device for storing and processing data. Very good. Electronic device used to store and perform different tasks. That is correct, Ronak. I'm waiting for some more answers. My question is, what is a computer? There are total 51 students in this meeting as of now, and some are joining. So I'm expecting good responses and quick responses. That's great. Zaid has answered, processing data in accurate formats. Chirag has answered. Hari has answered. Akash has answered. Okay, good. Fantastic. Your answers, Tejashri and Shivansh. Great. Fantastic. Okay, let me answer this question. Your answers are correct. I'm very happy that you are answerable. We say that computer is an electronic machine that processes the data. Okay, this is a very simple and sweet definition of a computer. I'm not thinking anything how my data will come, how my data will be displayed, how my data will be stored. I'm not thinking. I'm just putting most fundamental definition. Computer is an electronic machine that processes the data. Why electronic? You will agree. If you open your desktop or laptop out of curiosity, you will find lots of ICs, okay? That is integrated circuit, IC, okay? Your motherboard has large number of ICs. So it's electronic machine. And processing can be any operation, like you have studied C programming in SEM 2, or you may be studying Java or Python in this semester, Java, I think. So you arrange numbers from max to mean. Okay, it is called sorting, SORTING. This you must have done in C programming. Like I want to prepare a merit list for some exam. Let us say DLCOA, IA1. I want to prepare a merit list. So I will arrange all marks in descending order, that is max to mean. That is my processing. Okay. Now, when we know what is a computer, the simple and sweet definition, very fundamental question is how my data is presented in the computer. I repeat, computer is an electronic machine that processes the data, okay, or information. Let's use a word data. Agreed. The question is that how my data is presented in the computer. Okay, let me clarify. If we talk about human, all of us as a community, then if I want to present data, I use different symbols. Okay, what I use are alphabets or digits, combination of alphabets and digits, and I will present the data. Like I want to provide data as my name, okay? Then I will say ATUL. So I'm using alphabets. Or I want to present data for my mobile number, okay? Then I will use digits. Point is, human use alphabets, digits, combination to present the data, okay? But what about computer? Typically, let's take one specific case. Let's talk integer data, okay? Let's not be very general. Now, previously what we talked is very general, any data, alphabets, digits. Let's talk integer data. So if you see, my question is how we represent integer data. That's very simple. What I do, all human community we use a decimal number system. Okay, you can see a phrase decimal number system, digits from 0 to 9. Okay, and by combination of this digit 0 to 9, I represent any integer data. It can be 99, it can be 777, or it can be 555, or 123. So for human, when we talk integer data, we always talk digits 0 to 9. That is called 10 symbols, 10 digits. That is decimal number system. Okay, everybody knows. And if you think why we use decimal number system, okay, why we human use decimal number system, why only 10? That means 0 to 9. Why not other possibilities? That answer is also very simple. Answer is, we use decimal number system, or human use decimal number system, because there are 10 fingers. Okay, and because we have 10 fingers, we can naturally count 10 different digits 0 to 9. Nothing 0 to everything, that is 9. So decimal number system is so common. Point is, how we represent integer data in computer. Okay, now let's bring machine. One end is human, other end is machine. Can you tell me what is your thought how integer data is represented in computer? Any answers? Okay, I can see some responses. Good, very good. Looks like you are taking efforts looking at your answers. Good. Yes, all the answers are perfectly correct. When we talk integer data in computer, how it is represented, then we always represent integer data using two symbols, 0 and 1, called bit. Okay, plural is bits. It stands for binary. You can see BI stands for binary, and this T is the last letter of this word digit. So it is called BIT, that is bit, and plural bits. So all integer data we represent in computer using bits. Okay, 0 bit and 1 bit. That details immediately we will not go for. Okay, we will go chapter wise. So we will not think what is 0 and what is 1. I will add only one statement. 0 is a low voltage and 1 is a high voltage. Okay, 0 is a low voltage like 0 volt, and 1 is a high voltage like plus 5 volt. Okay, that all details will come as we go ahead. Now you will see there is a very clear cut gap visible. Okay, if you are alert for last 15 minutes, 15 minutes, You must have noted we human talk decimal numbers and computer talks binary numbers or bits. Two question comes. Question one is, what are common bases or number systems? One is what human use, that is 10. Other one is what computer use, that is 2. Okay, so what are the common bases? That is question 1. And second question is how we convert data of human, that means decimal, observe it, observe this. Okay, how we convert data of human to data of computer, that means binary. I repeat again, because now our environment is created. Okay, so the question is, there are some gaps. Okay, question 1 is, what are the common bases or number systems? Human use 10, decimal, computer use binary, that means base is 2. And how I will convert human data to machine data? For that, I need to study something. Okay, automatically it will not happen. And for that, we use a small table. If you have a look, and in that table you will find most commonly there are 4 number systems used when we think about computer and applications. One is decimal, base is 10. There are 10 digits, 0 to 9. Second is binary, base is 2. Only 2 symbols, 0 and 1. This is normally called bits. Okay, these are most common. This is human and this is machine. Here human is talking, here machine is talking. Okay, but other than these 2 number systems, there are 2 more number systems which are commonly visible. One is octal. Octal means 8. Okay, base is 8. And there are 8 digits, 0 to 7. There are 8 digits, 0 to 7. And fourth one is hexadecimal, whose base is 16. Now this is slightly weird, okay, because in hexadecimal we use digits from 0 to 9. Okay, so these are 10 different symbols, 0 to 9, and we use alphabets A, B, C, D, E, F, such that A represent value 10, B represent value 11, C represent value 12, D represent 13, E represent 1 4 and F represent 1 5. So you have 0 to 9 and A to F alphabets. A represent 1 0, F represents 1 5. 0 to 15, total 16. Okay, base is 1 6. Now I will ask you one question. Okay, let me see what are your answers. In hexadecimal number system, there are digits from 0 to 15. Okay, 0 to 15, 1 5. Okay, then why we don't represent those using only digits? Why we need alphabets? Why there is A, B, C, D, E, F? Directly say that in hexadecimal my numbers are 0 to 15. Why you need alphabets? It's your question. Let me see what are your answers. Yes, that's a good answer, Chirag, and what you're referring is perfectly correct. The reason is that there is nothing wrong in using digits from 0 to 15. Yes, Vitika is correct. Okay. See, theoretically, there is nothing wrong. It's perfectly all right. There are digits from 0 to 15. But now the problem is that if you say some value like 12, okay, let's take this particular value. Then is this particular value is decimal or is this particular value is hexadecimal? Okay, for that, rather than representing 12, we always represent 12 as C. Okay, so basically why we use alphabets? Okay, let's get back to our question. We use alphabets to avoid confusion between other number systems. Okay, so every number system will be unique. There is no overlapping. Okay, it will not happen. I'm getting confused looking at a particular value. Is it decimal or is it hexadecimal? Okay, for that, those alphabets are used, A to F. Okay, now I'm talking for about 40 minutes and I'm teaching for about 30 minutes. So it's a time where I will raise one question, and my question is, any questions? If you have any questions, definitely you can raise and I will answer that question. Otherwise, whatever we have discussed, we will bring in notebook. I will give you small dictation. Check if you have any questions. My question is, any questions? I'm expecting a two-way communication. It's not a monologue, it's a dialogue. Yes. Yes, I will answer this question. When binary, why to convert into others? That I will be talking in my next couple of slides. Okay. I have not talked about anything related to conversion yet. I have only raised the question. So this particular question, of course, I will be answering while teaching next two slides. So till that time, I think you can wait.
Sir, how hexadecimal is used in computers?
It's a good question. Why to do convergence?
Hello.
If there are no questions, then please reply. No questions. That is NQ. You have to be familiar with my dictionary. You know, one dictionary is yes, all is good. Second one is NQ. That means no questions. That looks better. Yes. 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 Okay. Now, can we bring this all concepts in notebook? If you are ready, type YES. Once again, the same magic word. Okay, that's great. That is how we communicate, you know. Okay, so let's write what we have gathered. Okay. So I'm not teaching now, I'm dictating for some time. I hope everybody is with the notebook and pen. And here we go. The title of our writing is number systems. Okay, we are going to write about introduction to number systems. So you can give a title, number systems. Okay, let's go ahead. Point number 1. I'm dictating, you are writing in notebook. Point number 1. Computer is an electronic machine. Computer is an electronic machine that processes the data, bracket information. Computer is an electronic machine that processes the data, bracket information. Point number 2. Data is presented using different symbols. Data is presented using different symbols like alphabets and digits. Data is presented using, yes, I'm repeating second point. Data is presented using different symbols like alphabets and digits by a human. Data is presented using different symbols like alphabets and digits by humans. Go to point 3. Data like integer data is presented, this is point 3. Data like integer data is presented in computer using symbols 0 and 1. Data like integer data is presented in computer using symbols 0 and 1 called bits, bracket binary digit using symbols 0 and 1 called bits, bracket binary digit, bracket done, and same integer data, we are writing 0.3, and same SAME and same integer data is represented using digits 0 to 9 by human. Same integer data is represented using digits 0 to 9 by human. Let me repeat this point number 3 because it's a big one. It's basically a comparison to bring number system. Okay, so just go through it quickly. Point 3, I'm repeating. Data like integer data is presented in computer using symbols 0 and 1 called bits, bracket binary digit, bracket done, and same data is represented using digits 0 to 9 by human. Point 3 is complete. Point 4. Humans use 10 symbols or digits. This is point number 4. Humans use 10 symbols or digits called decimal number system, and computer use two symbols TWO. Computer use two symbols called binary number system. I repeat, point 4. Humans use 10 symbols or digits called decimal number system, and computer use two symbols called binary number system to present data. That completes 4th point. Go to last point, point number 5. There are 4 number systems. There are 4 FOUR number systems most commonly used as follows. Point number 5. There are 4 number systems most commonly used as follows. I will wait for 2 minutes. You have to write this table. Either you write this table or you can take a pic, and then afterwards you can write the table. After every lecture, I will share my PPTs in PDF format. They will be available to you through our app. I repeat again, I will wait 2 minutes. Either you write this table or you can take a pic and write afterwards, but this is 0.5. And after every lecture, I will convert this PPT in PDF, and all PDF I will be sharing for your reference in our app, where there are notes. You will get this PDF. I will wait for 2 minutes. Meanwhile, if you have any questions, you can also raise your questions. It's a small table. I think you can quickly write also. Okay. Shivansh is asking a question, why we have not used alphabets in case of octal like hexadecimal. Okay, that's a good question, and very simple answer is, if you see, for octal number system, there are only 8 symbols or digits. So those digits are not exceeding 9. Okay. In hexadecimal, we go up to 1,5. So the probability in octal is less. Okay, what I was talking 10 minutes before, key confusion and all that. And very primary answer. Okay, let me give a very simple digital answer or primary answer. Octal number system is nowadays totally outdated. No system use octal number system. No computer system use octal number system. Why this is added? This is added because the very old computers, they were using octal number system originally. And because it is totally outdated, there is no need to generate any separate symbols for octal number system, because technically, if you see, decimal, binary, and hexadecimal, these are the 3 practically used number systems. Okay. And if you see columns in my table, you will find that octal number system is not used anywhere. Observe it. So your question, simple answer is, octal number system we don't use anywhere, so there is no need for special symbols. That's a good question. It's a good observation, I will say. Okay, Harsh has one more question. How hexadecimal number system in computer? That's a great question. Let me answer that question. But one thing is that in single semester, you may not get the answers of all your questions. Okay, you have to go for a journey called engineering, and that journey is for 8 semesters. Anyway, let me answer the question of Harsh. And then Ronak. Okay, let me answer to Harsh. Hexadecimal number system we extensively used in microprocessor. In semester 4, you will study a subject called microprocessor, and you will again meet me in semester 4 for microprocessor. So when we program microprocessor, we extensively used hexadecimal number system. And you will see in a subject of microprocessor. That is the answer to Harsh. And let me answer Ronak. We use binary number system because for binary number system, you require minimum number of bits. If you take any other number system, then your permutations, combinations will increase. It's a binary, there are only two symbols. And whatever is minimum, we use it at machine. It's very simple. I think there is further query by Vivek. Let me check what Vivek has asked previously. I think I have answered that question. Vivek, you can, Vivek, if you have any question, you again put it, because I think your question might have missed out. So still, I will wait for 1 minute before I go ahead. Our 5 points are complete and my dictation is also complete. So time to move. If any questions are still there, you can type. Let me answer it. Okay. I think we can go ahead. If all is good, just type YES so I can go ahead with the further part. Now we are in number systems. Yeah, okay, fine. That's very important because I also understand that I'm reachable to you and there are no technological problems. Anyway, now I'm not dictating, I'm teaching. Okay, so focus. 5 points I have dictated. Number systems we have brought. Let me start from this table. I'm teaching, I'm not dictating. If you see this table very carefully, you will find that decimal number system is extensively used by human. Binary number system is extensively used by machine or a computer. Octal number systems are totally outdated. Still we will refer because it's an old system. Old is gold, so we will refer. And hexadecimal number system is also used typically in microprocessor. Okay, so time to go and explore. Here we go. Now the $1 million question is that I'm a human. All our community is a human community. If my data, let's talk integer data, okay? Even if I'm calling data, let's be very specific. Let's talk integer data. Okay. If my integer data is in decimal number system, like my data is, let us say, 99, then how that data my computer represent, how that data looks in binary, and that we do using convergence. Okay, there was one question why we study convergence. Now here there is an answer. See, there is a gap. Okay, if you are good listeners and if you are with me, then what human use is decimal number system, what computer use is binary number system. Why binary? Minimum digits, and because it is minimum, we use in machine. But now the question is how they are compactable, because their symbols are different. To get that compactability, we must know how we do those conversions. Okay, they are basically translations. One person knows English, doesn't know French. Other person knows French, doesn't know English. There is a gap. And how we bridge that gap? We being translator. We do conversion, French to English, English to French. And these are the conversions we will be focusing. Have a look. These are my number systems. I already said decimal number systems are for human. Binary and hexadecimal, it is for machine. Octal, we are only studying. It's not used anywhere. And these are the four possibilities. Okay, my data can be here, my data can be here, my data can be here, my data can be here. Okay, if my data is in decimal, how it look in binary? If my data is in binary, how it will look in decimal? If my data is decimal, how it will look in hexadecimal? If my data is hexadecimal, how it will look in octal? That translation is called conversion, and these are the possibilities. Number one, human talks decimal, get into machine binary. Machine talks binary, get into decimal. This is number two. Number three. Number four. Number five. And number six. If we observe carefully, you will find total 12 conversions you should able to do. Why 12? Because every arrow is one conversion. Arrowhead, I will say. Decimal to binary, binary to decimal. Decimal to octal, octal to decimal. 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. 8 plus 2, 10. 10 plus 2, 12. Total 12 conversions. Okay. You know why we need to do convergence? How many types of convergence? 1, 2. Okay, and let's immediately start with those conversions. Okay, we will start with a conversion from decimal to binary. Okay, we will start here. Here we will start. Let me point it. This conversion we are going to start. Decimal, human talks decimal, get into machine called binary. And we are only going to focus integer data. I am repeatedly saying, to manage complexity. Okay, we are not going to talk alphabets, because the next question will come in your mind, how we represent alphabets which human talks into machine, which is a perfect question. But that I'll be talking little later. I will talk, but here only I will talk integer data. Okay, conversion of integer data. And this is very important for exam. This normally comes for about 4 to 5 marks. Okay, at least some conversion you will get in examination. Fine. If all is good, type YES. Let me see how many of you are promptly responding. That tells me how much you are concentrating. Okay, anyway, good. Let's continue. Okay, we will complete one conversion and then we will go back to some writing. So I'm teaching. Let's start one conversion, decimal to binary. Okay, now most of the conversions I will be teaching in two phases. One phase is how, okay, and second phase is do. How refers to algorithm, do refers to implementation of algorithm. Okay, how to do, that is a question. How to do, of course, conversion. How refers to algorithm, do refers to implementation. How to do, so we will start with algorithm and we will go to implementation. That's two-step process. Let's start with the algorithm. Algorithm is very simple. Okay, I hope you are going to colleges, started with sessions, so little bit understanding or information you may have or you may not have. Let's go. What is the algorithm? Focus completely, because this algorithm will be repeated, okay, for other conversions. So focus max. What we do, we start the conversion. Okay, you know how to write algorithm. This is an algorithm for converting decimal to binary. We start, you divide decimal number by 2. Why you divide by 2? Because my target base is binary. Okay, my target base, target means where you want to convert, it's binary. So you divide by 2, and when you divide, you get 2 results. When you add, you get 1 result. Subtract, 1 result. Multiply, 1 result. But when you divide, you get 2 results. One is quotient, another is remainder. That's why there are 2 operators in programming languages. one for quotient, other for remainder. What we do, after you divide by 2, you record remainder, okay, and your new dividend means numerator, okay, you divide numerator by denominator. Your denominator is always fixed, that is 2, okay. Your numerator will change, so you change your numerator to a new dividend, which is quotient. Don't worry, I'm just going through the algorithm, okay. So you must know algorithm and then you do. My question was how to do conversion. How refers to algorithm, do refers to implementation. That's the answer, how to do. So new dividend is a quotient. Repeat this process. Again divide by 2, again divide by 2, till your numerator is less than denominator, okay. This you will see in next 2 minutes. I'm just going through the algorithm. Finally, what we do, once I stop division, I will collect all remainders which are bits, okay. So remainders will give you the bits of binary from bottom to top, and I will stop, okay. This is the end of my algorithm. Just read it once. I will wait for a few seconds and then we will do it, okay. We will do conversion. So just go through. Okay, I think algorithm is very clear. Now let's do it. This is all animated in my PPT. So I save all writing time and all that. Entire focus is in understanding and making a note. Question is, convert 125D, D means decimal, okay. 125 decimal, base is 10, in binary, okay. That is the question. Let's apply the algorithm, this algorithm, okay. .125 decimal is equal to how much binary? That is a question. 125 decimal is equal to how much binary? That is a question, okay. Let's apply the algorithm. You can see I'm dividing decimal number by 2. I said your denominator is always 2. The target where you are converting, okay, binary, so base is 2. Now if you divide 125 by 2, you will get quotient as 62. 2 6 are 12, 2 2s are 4, 5 minus 4, remainder is 1. You can see this is my remainder. I'm keeping record of remainder, and this is my quotient. Now this quotient will be my new dividend. That means numerator. Here I said, if you recollect, observe it. New dividend is quotient. So this is my new dividend. Divide by 2. If you divide 62 by 2, you will get quotient as 31, remainder as 0. Divide by 2. If you divide 31 by 2, this is my quotient, this is my remainder. Again divide by 2. If you divide 15 by 2, this is a quotient, this is a remainder, again divide by 2. If you divide 7 by 2, this is a quotient, this is a remainder, again divide by 2. If you divide 3 by 2, this is a quotient, this is a remainder, again divide by 2. If you divide 1 by 2, division is not possible. So your remainder is 1 and your quotient is 0. Okay, why quotient is 0? Because division is not possible. Here I said, observe it. Repeat division till dividend is less than divisor. That is step 4 in algorithm. Dividend is less than divisor till. Okay, now you will see that at this particular point, my dividend is less than divisor. So I stop my division. Division is not possible, so my quotient is 0 and last digit is my remainder. Okay, I will keep this as it is and collect all bits from bottom to top. Observe it. So if you see, I'm collecting all these bits from bottom to top. You can see 1 1 1 1 1 1 1 1 1 0 1 0 and 1. So this last topmost bit, this is called as a bit, is 1. Okay, that's why this arrow is visible. This is the topmost bit, which is the last bit. So 125 decimal looks like 1111101 in binary. So this is what machine looks and this is what human looks. Same data but different looks. That is what is the conversion. Check if you want me to repeat any step or you have any questions before I go for some more details in this conversion. So check if you have any questions. My question is any questions, please check. Okay, that's great. NQ. Still, I will wait if you have any specific question because some more details I want to bring in this conversion. Okay, this is the most simple conversion to start with. So there are no questions. Very nice. Time to go ahead. Focus. Let's get some important terms. At many places, these terms I'm going to use. Okay. If you see 125 decimal looks 1111101 in binary. Okay. In this binary, first bit with highest position, okay, this is the highest position and this is the lowest position. Okay, the bit at highest position is called MSB. It stands for most significant bit. Most significant bit. This is called MSB. And the bit at lowest position, it's called LSB, that is least significant bit. Least significant bit. MSB opposite LSB. Okay, most important concept. Now let me explain with some example. Okay, I'll be writing slightly, it will be a rough writing. Okay, everybody must have enjoyed our school days. Okay, let's go back to school days. And in school days, we used to say units place, tens place, hundreds place, and thousands place. Okay, in school days, we used to learn units place, tens place, hundreds place, thousands place. Okay, very fundamentals. Say for example, if this is my number, okay, my number is 123. I'm talking decimal number. Okay, this is my number. Then this particular place is called as units place. This particular place is called as a tens place. And this particular place is called as hundreds place. Okay, this everybody knows. This is a units place, tens place, hundreds place. Can you tell me why it is called as units place?
Because its value is 1.
I repeat my question. If my number in decimal is 123, referring to our school days, 3 is called units place, 2 is called tens place, 1 is called hundreds place. Can you tell me why? Chirag is telling units, it has only one digit. So everywhere there is one digit. In tens place also there is 2, single digit. In hundreds place there is 1. Okay, now Chirag has explored tens as 2 digit and so on. Okay. Place value is unity. That's a better answer, Harsh. Any other answers? I will wait for a few seconds. Okay, let me answer that question. Yes, Shivansh has got still better answer. Value of units is 1. Yes, that's why it is called as units place. Okay, let me answer it. Good attempt, very nice. The reason is that this position is called 0, this position is called 1, this position is called 2, and so on. Okay, listen my every word very carefully. My words are assets. This position is 0th position, this position is position 1, and this is position 2. Okay, if you observe carefully, this particular number is a decimal number. I think 2-3 times I said when I asked this question, 123 is a decimal number. Okay, so this particular digit is 10 raised to power 0. This particular digit is 10 raised to power 0, and anything raised to power 0 is 1. That's what is called units place. This position is 1. 10 raised to power 1 is 10. That's what is called tens place. This position is 2. 10 raised to power 2 is 100. That's what is called hundreds place. And you can go ahead. That means these numbers are very, very important. and these numbers are called weight, WEIGHT. These numbers are called weight, WEIGHT. Okay, I'm just writing quickly, so might be slightly rough, but it is okay. These numbers are called weight. Okay, and why suddenly I shifted from binary to some example in decimal? Reason is same way, this position is 0, this position is 1, this position is 2, this position is 3, this position is 4, this position is 5, and this position is 6. Okay, the bit with highest weight, you can see weight is equal to 6. You know what is a weight? The bit with highest weight is called MSB. So if somebody asks you a question after this session, what is MSB? That's the takeaway. The answer is a bit whose weight is maximum, it's called MSB, most significant bit. And the bit whose weight is minimum, weight is equal to 0, it's called LSB. Because these weights are same whether you talk decimal or whether you talk binary. Basically, they are numbers. Okay. Check if you have any queries up to this. If you have any queries, then I will answer those queries. Otherwise, we will bring it in notebook. So my question is, any questions again? Okay. There are no queries. That's great. If you are ready with your notebook and pen, just acknowledge with our magic words. Okay, I will repeat. Don't worry. I have one question, and that question is from Shivansh. How you will define a weight? Okay, I will answer that question. The answer is weight is the position of bit or digit. If you talk about binary number, it is a position of a bit. Position of a bit. It's called as weight. Position of digit. It's called a weight if you take other number systems. Okay, that is the answer to your question. Okay, now we will bring all this in the notebook. Again, I'm dictating for around 5 to 10 minutes. Okay, let's go ahead. I think I have dictated you 5 points. Let's move after that. Okay, give the title. Title is Conversion between number systems. Title is Conversion between number system. Conversion between number system. Okay, go to the first point, point number 1. Translation of, this is point 1. Translation of data. Translation of data like integer data. Translation of data like integer data from one number system. Translation of data like integer data from one number system to other, it's called conversion. Translation of data from one number system to other, it's called conversion. Go to second point. There are 12 common conversions. There are 12, 1, 2. There are 12 common conversions as shown. I will wait for 1 minute. आपको ये डायग्राम बनाना है. If you want, you can take a peek also. ये मैं इरेज नहीं कर रहा हूं, ये जो मैंने लिखा है, क्योंकि आगे डिक्टेशन के टाइम मुझे वो रेफरेंस लगेगा. ओके, लेकिन डायग्राम क्लियरली विजिबल है, ये कन्वर्जन का डायग्राम. ओके, आपको वो बनाना है 1 मिनट में. इफ यू वांट, यू कैन टेक अ पीक ऑल्सो. दिस इज पॉइंट नंबर 2. मोस्ट कॉमन कन्वर्जन्स are as follows. There are total 12 conversions as shown. That was the last statement. Okay, I think we can go to the third point. This diagram is a second point. 12 conversions. Okay, ठीक है. Let's go to third point. Decimal to binary conversion. Third point is decimal to binary conversion. Okay. Write one statement for third point, decimal to binary conversion. Okay. Basic algorithm for converting decimal to binary is as follows. Basic algorithm for converting decimal to binary is as follows. Again, I will wait for 1 minute. आपको ये algorithm लिखना है. आपको चाहिए तो आप पिक लेके बाद में भी लिख सकते हो, लेकिन आप लिखेंगे तो अच्छा है. It will be more clear to you. So I will wait for 1 minute. You have to write this algorithm. There are total 6 steps, clearly visible. मैं वो रेड कलर का इरेज नहीं करूंगा, मुझे वो लगेगा आगे. So point 3, you are writing algorithm. Okay, we can move. Go to the fourth point. The fourth point is the example and write this example that we discussed with all details. Okay, details like MSB and LSB. Okay, I will give one statement after this writing is complete. So show this example. This is point number 4. Convert 125 decimal in binary. That is the question or example. Show the process, how algorithm is applied, what is the result, MSB, LSB. Complete it. Wait for 1 minute. This is basically all remainders, and these are all quotients. And this is a fixed denominator because the base is 2. Okay, I think we are about to complete writing this example. Just write one statement after this example. Yeah, I will show previous screen. Karthik, just give me 1 minute. One statement I will dictate and then I will show previous screen. No problem. Okay, just write one statement in this 4th point after example. Okay. Weight is defined as position of a bit. Weight is defined as position of a bit or a digit. Weight is defined as position of a bit or a digit. Continue with next statement. A bit with maximum weight, it's called MSB. A bit with maximum weight, it's called MSB. Bracket, most significant bit. A bit with maximum weight, it's called MSB. Bracket, most significant bit. And a bit with minimum weight, it's called LSB. Bracket, least significant bit. Bracket, least significant bit. Okay, so that dictation is complete. What is weight, MSB and LSB? So Karthik wants to see the previous slide. So let me show the previous slide. This is the previous slide. If all is good, type magic words. We will go ahead. We are in the last 35 minutes of today's session and we are in convergence. Okay, fine. Okay, so now I'm not dictating, I'm teaching. Okay, let's go for the opposite conversion. So our one pair will be complete for the day. I'll just erase all this. Now this we have already written. Okay. And this all we have discussed. What is MSB? What is LSB? Fine. Now the question is that how we do translation from binary to decimal. The opposite. Okay, machine talks binary and you want to deliver it to the human. Okay, so this particular translation is from human to machine. Now let's think about machine to human, and for that the algorithm is a simple multiplication. And by common sense you will agree that here when I'm trying to convert decimal to binary, my algorithm is division by 2, because that's the target binary system. And when I want to go from binary to decimal, division will become multiplication. It's like a compensation. Here is the algorithm. Have a look. We start the algorithm. We multiply every bit by 2 raised to n. Okay, please focus. We multiply every bit by 2 raised to n, where n is weight of the bit. Now you know what is weight of the bit. I have dictated also position of the bit or digit is called weight. So this n is basically the position of that bit. Okay, we will see example. Of course, position starts from 0 and it goes to max. Okay, as we move. And finally, when you multiply every bit individually, all those partial products you have to add, because every bit you will multiply by 2 raised to n. Okay, maybe there are 5 bits, so you will multiply bit 1, bit 2, bit 3, bit 4, bit 5. So all those multiplications, I will say partial product, you have to add to get the result. Okay, that's the typical algorithm, multiplication by 2 raised to n. My question was how we do, or how to do. How refers to algorithm, do refers to implementation. So how we have discussed. Let's do it now. Let's go to a question. Question is, convert 101011 B for binary. Okay, so this is my binary data, that means in machine, into decimal number system. Okay, that is the question. Now you can see in this particular binary data, oops, I'm sorry. In this binary data, I have identified my LSB. Okay, bit position 0 is my LSB. Okay, I start from LSB and it go to MSB. Okay, this process I will go from LSB to MSB this way. So I take this LSB, you can see, which is 1, and I will multiply by 2 raised to n. I told you in my algorithm, if you are listening carefully, that when I multiply by 2 raised to n, n is the weight or it is a position of the bit. Now this position is 0, so I'm multiplying by 2 raised to 0. And anything raised to 0 is always 1. So 1 into 1 is 1. This is my partial product. Okay. Then I will take next bit. You can see position of this bit is 1. So I will multiply by 2 raised to n. That means 2 raised to 1. My partial product is 2. Then I will take next bit. Position of this particular bit is 2. So I will multiply 2 raised to 2. But 0 multiply by anything, result is always 0. Then we go to the next bit. Its position is 3. So I will multiply 2 raised to 3. Result is 8. Then I will take next bit. Position is 4. I will multiply 2 raised to 4. But anything multiplied with 0 is always 0. I'll go to the last bit. Position is 5. So 2 raised to 5, 32. And you have to take a sum of all these partial products. So if you add 32, 8, 40, 40 plus 2, 42, 42 plus 1, 43. So this value is 43 in decimal. So by using multiplication algorithm, we convert binary data into decimal. Okay. Check if you have any questions here. Yeah. Harsh, we will be writing about that algorithm. Don't worry. I'm teaching. That's why I'll be going to the previous slide. Okay. And this all I'll be sharing with you in PDF. Like sometime before I said that this all I'll be sharing in PDF. So you will have notes also, which we are writing this PDF also, and normal notes are also there in soft copy format. Okay. Okay, so there are no questions. All looks good. Today is day 1, but still we are doing great. Almost discussing for 2 hours. So now there is a small exercise for you. Okay, let me erase this. And this is a homework for you. Okay, I'll give you time to write. I'm just telling you now that you have to convert decimal to binary. There are 5 conversions, and you have to convert binary to decimal. There are 5 conversions. Okay, this is a small homework based on what discussions we did. Before that, can we bring this in notebook? If you are ready, type magic words. We will write it. Okay, that's great. All is good. So go to the notebook. I'm dictating and you are writing. Give the next title. Title is Conversion of Binary to Decimal. Conversion of binary to decimal. Conversion of binary to decimal. That is the title. Now we will keep it separate conversions. Okay. Conversion of binary to decimal. Okay. Now write down algorithm. Algorithm. I will wait for 1 minute. You write this algorithm. If you want to take a pic, you can take a pic. Always remember the question, how to do. How is the algorithm, do is the implementation. Okay, I hope you are about to complete. It's a small algorithm. Okay, after that, let's continue. Example. Example. So you can write this example. Convert 101011 binary in decimal. I'll wait here for another 1 minute. Example for binary to decimal conversion. Okay, let's move on. I can see your responses, and this is a homework for you. You take a pic of this. Okay, don't write it because writing will take a minute or two. Take a pic of this and then complete that homework. Next time I will ask you. So this is a homework for conversions, decimal to binary and binary to decimal. Okay, now focus, because mainly I'll be teaching. Only small writing might be there for remaining time of today's session. Okay, let's go ahead. I'm teaching now, I'm not dictating. Now let's think how we convert decimal number to octal number. Okay, now you will find that this process is repetitive. Once you understand decimal to binary and binary to decimal, two algorithms, one is divide and second one is multiply. Same algorithms will be using for remaining conversions. Okay, let's start with decimal to octal. This is the algorithm, and if you see this algorithm, favorite operation called copy paste. Okay, while making this slide, I just copy pasted decimal to binary conversion slide here, with only one difference. Instead of 2, here I have written 8. Observe it. Okay, rest everything is same. You can see, start the algorithm, divide decimal number by value 8. In binary conversion, we used to divide by 2. Okay, and keep track of remainder. New dividend is a quotient. Repeat division till dividend is less than divisor. Collect all remainders from bottom to top. Everything is same, and stop. Okay, so you don't have to actually study each and every conversion separately. If you understand one pair, remaining conversions are based on that. Okay, let's see how this algorithm we apply, how we do it. Observe this example. Now this is in table format. Okay, this example is in table format. I want to convert 125 decimal to octal. So this is my 125 decimal number, and I will divide by 8. Okay, 8 ones are 8, remainder is 4, 8 fives are 40, final remainder is 5. Okay, so this is my remainder R, and this is my quotient. Okay, divide 15 by 8, 8 ones are 8, remainder is 7. 1 divided by 8, division is not possible, so stop the division. Quotient is 0, and whatever is left over, that will be your remainder. And pick up all the digits from bottom to top. What we get is 175. So 125 decimal, D for decimal, is equivalent to 175 octal. Just replication of decimal to binary conversion, except instead of dividing by 2, we are dividing by 8. Otherwise, algorithm is same. Okay, let me go ahead with opposite, converting octal to decimal. Have a look how to convert octal into decimal, and for that, this is the algorithm. Again, if you are with me, you will find it is a copy paste of binary to decimal, with only one difference. Instead of writing 2 raised to n, I'm writing 8 raised to n. Okay, rest everything is same. Yes, that's perfect. Multiply by 8. Okay, power of 8, it is called weight basically. And this is the example where we apply. Have a look. I want to convert 724 octal to decimal. Okay, एक बात समझ लो कि one way you can write octal number in this format. दो फॉर्मेट से आप नंबर को रिप्रेजेंट करते हो. ऑब्जर्व इट. एक ये है, ओके, 724, ओके, सफिक्स 8. दिस इज वन वे. या फिर ऐसे भी लिख सकते हो, 724 फॉलोड बाय कैपिटल O. बोथ represent the same thing. 724 octal, 724 octal. Okay, what we do, we take first digit. Observe it. This is my position number 0, this is my position number 1, this is my position number 2. Okay, so I take first digit, that is 4, and I will multiply by 8 raised to 0. anything raised to 0 is 1, so 4 into 1 is 4. Then I take second digit and I will multiply by 8 raised to 1. I will take third digit and I will multiply by 8 raised to 2, 64 into 7, and I will add all partial product, very similar to binary to decimal. Only instead of 2 raised to n, you will multiply 8 raised to n. Okay, can we bring this in notebook? Please check. Can we bring these conversions in notebook? So next session, we will continue with some more conversions. Expecting some responses. Okay, so let's get this in notebook and then we will summarize for the day. Okay, yeah, great, no problem. So let's continue. Now I'm dictating and you are writing. Okay, give the next title: conversion of decimal to octal. This is a title: conversion of decimal to octal. Okay, and write this algorithm. I'll wait for 1 minute. It is better if you write, because through that you will get practice of writing algorithm and you will identify that this is very similar to decimal to binary conversion, except digit is a difference. 2 replaced by 8. So write algorithm. I will wait for 1 minute. Of course, you can take a peek also. You can write later also. Normally in exam, all numericals are asked: conversion from decimal to binary or decimal to octal. But you must know what is the algorithm, because when you are actually converting, you are applying algorithm. So it's basically a two-step process: algorithm and example. Okay, I think we can move, because you must have noted it's almost identical, but still, because I should give chance so that you can put it in a best possible presentation, you can write in a best possible way. Okay, so here we go for example. You can write down this example: convert 125D to octal. This is in tabular format. If you want, you can write here remainder R, and you can write this as quotient, just for clarity. This way also you can solve numerical 3-column format. Okay, time to move. Give the next title. Title is conversion of octal to decimal. Conversion of octal to decimal. That is the next title, probably last title for the day. Conversion of octal to decimal, and make a note of this algorithm. I strongly recommend that whatever 1 or 2 minutes I'm giving, you write it rather than taking a pic, because by that writing you will better understand and you will keep it in mind what is the algorithm. Okay, I'm going ahead with example. And here is the example. Convert one, convert 724 octal to decimal. Complete this example. I will wait for 1 more minute. See how you can present your answer in examination. That is also visible in our example. Okay. And finally, this is your second homework. Now this you can take a pic and you can complete to get better hands-on on conversions. Okay, convert decimal to octal, 5 questions. Convert octal to decimal, another 5 questions. Okay, so total 20 questions I have given you for conversions. Okay, 4 conversions we have completed, and I have given you 20 questions for better hands-on, for understanding the algorithm. Complete it before we meet next Friday. Okay, let me start the next discussion. Okay, this all we will continue next Friday. I'm just starting it just to give the little idea, I will say, and then we will continue next Friday. Now, decimal to hexadecimal conversion is again similar to decimal to binary. We divide by 1/6 and we keep track of remainder. Okay, you can see again this algorithm is similar to decimal to binary or decimal to octal, what we did. But now this is little tricky. You need to be little careful in this particular conversion, because in hexadecimal along with digits we also use alphabets. Okay, that all you have noted also. We did it in initial 1 hour. And effect is that if you do this division and if you get some remainder which is more than or equal to 10, you have to represent it by alphabet. Okay, like 10 is represented by A, and like that F indicate 1/5, that table you have written. Okay, that's the extra work, or I will say thought, which is involved in this conversion. Otherwise it is division. Generate remainders, all remainders form your answer, and all quotients you will go on changing. Okay, how it looks, just have an example. I want to convert 1234 decimal into hexadecimal. Okay, don't worry, this is the point we will continue next Friday, but I want to do 2 references for clarity. So what we do, 1234 we divide by 1/6. Okay, so if we do this division, then what we find is 16 sevens are 112. Okay, remainder is 11. 123 minus 112, remainder is 11. We take 4, so it becomes 114. Again 16 sevens are 112, so 2 is a remainder. Okay, straightforward. This is simple. This is remainder. Again we divide 77 by 16. 16 fours are 64. 77 minus 64 is 13, and 13 is represented by D. Observe it. This is the additional requirement. You have to remember A to F, 10 to 15. Okay. Further division is not possible if you see. So we stop the division. Quotient is 0, and whatever is the last value, that becomes my remainder. And we pick up bottom to top. So 4D2, 4D2 hexadecimal is the answer. 1234 decimal is equivalent to 4D2 hexadecimal. Okay, but like I said, this probably we can continue on next Friday. Okay, now last point I just want to introduce before we summarize. This we will not write, this we will write next Friday when we again continue with convergence. Now listen, and for that I will be using my slate, which is my Microsoft Word. Okay, just last 5 minutes to bring one word. Okay, let me make it readable. I always use Microsoft Word as a slate, so I can type and I can explain. Okay, see now, today we have started with convergence. Okay, and we have done 4 convergence. Okay, let me increase the font. In fact, I will increase this. You can read. Okay, so we have done 4 convergence. So C for conversion. Okay, now there is one more C, and this C is called code. Okay, I'm not talking about programming code, but I'm talking about some standard way of representation. Just listen very carefully for last 5 minutes. Suppose my number is 3. Okay, 3 decimal. Then 3 decimal I will represent as 1 in binary. Okay, let me write only decimal on one side and binary on other side. Okay, so this is my decimal and this is my binary. Okay, okay. Same way, if my value is 4, then it is 100. If my value is 5, then this is 101. If it is 6, then it is 110. If it is 7, then it is 111. If it is 8, then it is 1000. Okay, these all conversions you can do. I have taught you also how to convert decimal to binary, and I have given a lot of exercise also, homework also. Okay, now if you observe very carefully, you will find that definitely these conversions are correct. Okay, 3 decimal is 11 in binary. or 4 decimal is 100 in binary. But the problem is that if you see carefully, there are only 2 bits which are used to represent this digit. There are 3 bits used to represent 4 or to represent 5 or to represent 6 or to represent 7. Okay. And there are 4 bits to represent 8. That means every decimal requires different number of bits. Like 3 requires 2 bits, 4 requires 3 bits. Okay, 5, 6, 7 requires 3 bits, 8 requires 4 bit. And here what we need is some standardization. Okay, we cannot say that every digit in decimal requires different number of bits. It's not uniform. Okay, what you see is non-uniformity. There is no uniformity. We need that uniformity. Okay, I want that every digit 3, 4, 5, 6, 7, 8 should be represented by fixed number of bits. I repeat again, every digit should be represented by fixed number of bits. That we do using a concept called code. Observe it. It is not programming code. Okay, it's a code we use in number system. Okay, and why we use code? We use code for standardization. Okay, okay, we use code for standardization. And one such code is called BCD code. Okay, this will be discussing in coming session. I just want to give you some thought process why we need code. Okay, anyway, before we end this particular session, one more time I will raise a question, and my question is any questions? Please check if you have any questions. If you have any questions, then definitely I will answer. Otherwise, today we started with what is a number system, what are common number systems, what are the possible conversions, what is a conversion, why we need conversion, and 4 conversions we have completed out of 12. Okay, and we just introduce why we need code. Okay, there is one question. What is the purpose of standardization? Let me answer it. Once again, I will take this example which is visible. If you observe, every digit in decimal number requires different number of bits. For 3, I need 2 bits. For 4, 5, 6, 7, I need 3 bits. For 8, I need 4 bits. So I cannot say that every digit I am representing by different number of bits. I'm talking number. I'm not talking value. I must say that you take 3, you take 4, you take 5, you take 6, you take 7, you take 8. All these digits in decimal, I will represent by fixed number of bits, like 4 bits. That is called standardization, and for that we use code. And one such code is BCD. Okay, that we will be talking further. That is the last part we discussed. Okay, all important points we have noted also. So we are good to end for our today's session. That was a great start. Many things we discussed. We use our time in a most efficient way. So let's continue in the next week, next Friday, same time, that is 6:30. Okay. Thank you so much for your kind cooperation and take utmost care. Keep studying. Okay. Let's meet on next Friday. Complete the homework, 20 questions. Okay. Thanks a lot and have a good weekend. Anybody in the office? My
Thank you,
session is complete. You can close the session. Thank you.